Hello friends, good morning. This is Professor a.k.chaubey today again present for discussing some topics in physics under the heading Physics Made Simplest. Earlier we have been talking so many topics in different branches of nuclear physics and other physics. Today I want to talk some about nuclear transformation. Under the heading nuclear transformations, we can talk about the natural radioactivity, and we can talk about nuclear reactions. So these topics say a nuclear transformation means we are changing one system into other system. By natural process, in nature it is happening, or we can do it by using some projectiles, some beams, some ions, some heavy ions, some particles, accelerated particles. That means we can transform one system to other system by bombarding a suitable target by projectile. That is the nuclear reaction. So I will talk about the natural radioactivity and also induced. You can say this nuclear reaction means induced radioactivity. So this is natural and this you can call induced. Induced radioactivity. You know that in nature we see from the earlier experiments or research done by the Curie, Madame Curie, and then her husband and daughter, etc., whole family. And that is the Curie, discovered radium and polonium. Radium was used for the most of experiment in the nuclear physics by all research groups, starting from the Rutherford group, and the Madame Curie supplied the alpha source, that is the radioactivity, high concentration of alpha particle radium in the form of radium. So that radium and polonium also, these were two earlier discoveries by Curie. So radium was used for the artificial, you can say, induced activity or artificial activity also you can say. That is also artificial. You can have different names. So first I will talk about the natural and then about artificial. So what the natural activity is? The natural, I will talk about the nuclear transformation in general and particular, natural activity which was observed by the Curie, that this is the property of some substances, some and elements you can say, that they have natural radioactivity, means emission of some radiations from some elements That is by in nature, emission of some radiations from some elements without any external help. Means you are not providing any energy, you are not helping those elements to emit any radiation. If you provide some energy, means that becomes nuclear reaction or artificial transmutation. So natural transformation, nuclear transformation, or you can also call transmutation. Transmutation also means you are changing one system into other system by nature, means you have say some substance X, and if this gives something, it emits something, you get Y and plus Y. Means this thing, without any external aid, you are not pumping any energy. This is just in nature, by some process, it is changing into Y, and this is the emitted particle. Emitted particle, and this is a residual system. And this is the original. In nature, original system, any element by say any process, I am not telling any process now, this is transforming itself to some other element, and something is emitted, that emitted particle. So this is a natural thing. In nature it happens, and without any external aid, without any external help, this is emitting some particle. So this is called natural phenomena, and in nature it is observed that there are many elements which are emitting some radiations, and these radiations, when they come out, we get either new element or new isotope of same element, you can say. So that means there are some natural transformation and emission of radiations, or it is natural radioactivity, that is, natural and that is called, one is beta decay, the other is alpha decay, and another is gamma decay. Means in nature the systems are changing, transforming into other systems by natural way, and that is by emitting some radiations. So one category of emitted radiations, and that comes under beta decay, the other is alpha decay, and another is gamma decay. So what the beta decay? Well, beta decay, we know that this is the process that in which a electron type radiation is emitted. Electron type radiation is emitted. Means a particle which is very similar to electron. It is not electron, it is very similar to electron. Because there is something which is not exactly same. So it is electron type. It is electron in the sense that it is coming from the element. It is coming from nucleus. So it is different because electrons are not existing in nucleus. Electrons are coming out from atomic shells, outside the nucleus. So difference is that this is electron type, means it is not exactly coming out from the atomic shells. It is coming out from inside. So I am making it a little bit difference that it is electron type. Means if I have element X, well, this going to element Y, and we get a particle, this is we call beta particle. It is negative also and it is positive also. Two types of particles are there. That is, one is electron type, so that is called electron, which is the negative beta, and other is called positron, which is positive beta. Means it is also beta particle, similar to beta particle, but its charge is positive unit, 1 unit. Electron has got 1 unit negative charge, positron has got 1 unit positive charge. So positron is antiparticle of electron. It is also coming from the nucleus, because positrons are not existing outside the nucleus. In the atomic shell we have electrons only. So it cannot be of atomic origin. It is from nuclear origin. It is also coming from nucleus because it is nuclear decay. Atom, you can say that if you say this is not nucleus, it is coming from electron, atom. Well, I have definitely a strong argument against the natural emission of electron from atom, because electrons are bound in the atomic shell, revolving around the nucleus in particular radius. So they are bound, stable orbits. Atomic electrons only comes out when there is excitation, when some energy is pumped into the atom from outside agency. When you pump energy, this becomes excited state, and maybe excitation is so high that the electron comes out, that it becomes ionization, means emission of electron, and remaining thing becomes positively charged. Electron goes out. So that is the atomic electron. But for emission of atomic electron, we require some energy. We require some external agency. Either you heat the element or you bombard by some radiation, so that energy is transformed to the atomic electron in the orbit and it comes out. So there are many processes of emission of atomic electron. I am not discussing those processes. So beta decay is not an atomic phenomenon, because atomic electrons are bound. Bound means they require some energy to make the electron free from the atom. So the beta decay phenomena cannot be an atomic emission of electron. It is, then you will say that in the nucleus it is only neutron, proton. How it is that electrons are coming out from the nucleus? Yes, because this is decaying. So how they are coming out? Well, I give the example that in this X element there are many neutrons and protons. So suppose a neutron of this X transforms to a proton, because this is zero charge, this is mass, say 1 unit, this is 1 positive charge, mass also 1 unit. So remaining thing, if this is proton, this is neutron, well, remaining the here emitted particle, which I write electron, it must have a minus, because it is zero charge, so it must have minus 1 charge. And its mass 1 unit here, this also. So this mass should be nearly, it is not zero, but very small as compared to neutron-proton mass. So I write it 0. And then some energy, which I call as Q beta. Q beta is the energy of the beta decay. Means it is the mass difference of the parent nucleus and the daughter nucleus. So that is, you can say Q beta means the energy difference. And Q beta must be positive. If Q beta negative, the emission or the decay process will not take place. Because then Q beta negative means you have to apply some energy to make this Q beta positive. So if it is natural beta emission, Q beta must be positive. The energy means mass difference of initial system and the daughter nucleus must be positive. Only then I will not get that condition, I will not get the mathematical condition for that. But simply I am saying that without this positive, particle will not have come out, because this particle should have some energy also. If this is zero, means both masses are same. This particle may come out but with the zero energy, no energy. So Q beta must be positive. Q beta negative, decay is not possible. So neutron of any element is converted into proton by emission of electron. I think. So that is the negative beta decay. Similarly, a proton of element, mass 1 unit, charge 1 unit, it comes out from the system and it converts into neutron of 0 charge, 1 mass unit, plus it is the beta particle positive charge, so that charge balances and mass nearly same, and this is the Q beta positive. This is now positron decay, this is the electron decay. So the two processes of beta, these both are called beta decay, beta negative and beta positive. So this is a natural process. In nature, it is happening without any external aid, without any external energy supply. No energy needed, it is natural. And here you can say the mass difference is, this is mass slightly more than this. So it is not allowed by nature, because how this less mass, here more mass. So but this in the system, inside the nucleus it is possible. Well, free proton cannot decay to free neutron. But inside the system there are many other particles, many other proton neutrons. The system has got energy. So the difference of energy mass may be taken from the system itself. So it means inside the nucleus, when there are many particles, this proton can decay, because it can get the difference of energy from the system. But free proton cannot decay because mass of neutron is more. So, and this is possible because this mass is slightly more than this. So this is readily possible. But these two processes are called beta decay, beta negative, or beta positive. And I told you that this cannot be atomic phenomena, because in atomic decay, atomic emission of electron, some energy is required because electrons are bound. And moreover, whenever atomic electrons comes out by excitation, there is a hole created, means deficiency of electron created there. Some vacancy is created. So vacancy is filled by the higher orbit electron, and then there is always some emission of radiation, means X-rays. So the atomic de-excitation gives you X-rays of photons. So whenever there is emission of electron from an atom, you need some energy to overcome the binding energy of electron, and there is emission of X-rays or photons. So in the beta decay, we don't have any emission of photon or X-ray. Pure beta decay is possible. Gamma decay may be associated with beta decay, that is a separate thing. But pure beta decay is also possible, where there is no emission of photons or X-rays. So this beta decay process cannot be of atomic origin, because atomic electrons are bound, and whenever there is emission, we require some energy for excitation and then ionization, and their de-excitation gives you the emission of photons or X-ray. So remember that beta decay is a process which is a nuclear process. But then I say here, well, beta decay, you see here this, you can say neutron, proton and electron. Slightly I want to give more details of that it is observed that energy of beta is not a single value. It is continuous. Means beta spectrum, beta energy spectrum all energies from nearly zero to a maximum which is also called endpoint energy. That means beta spectrum is continuous, not a single value. So beta spectrum is continuous, not a single value. This means that our beta particles are like energy spectrum. We have E beta. While this is like this. This is a E endpoint or E maximum. So this is continuous spectrum. This is the energy and this is, you can say, intensity. So or number of particles. Intensity means number of particles. So and this means spectrum is continuous. All beta energies are possible, not only one beta energy. So remember that beta energy is continuous. So how this can be explained? Because you have the Q beta there, you write the equation that mass of the X, and here this mass in the units of energy, and here is the mass of the by and C square plus electron mass is the beta particle m naught C square, this, and then Q beta. This Q beta means the difference. When the energy of this mass, rest mass energy plus energy of E beta, you can say. Rest mass energy you can ignore or you can say very small. But E beta is there. More important is E beta. This is a constant, 0.511 MeV. So you can ignore rest mass energy, but this is the E beta. So E beta is different value. How this is that energy, difference energy is one value. Remember that mass of this X and mass of this Y, this thing, C square. This is one value. But E beta is different. So where the difference of mass is going? That this thing. So how the energy is conserved? So the energy conservation in beta decay, difficult to explain. So it was thought that there may be some other particle also coming out with the beta particle so that energy is conserved. So to conserve the energy, a new particle was thought that emission of another particle which can explain the energy conservation. And you remember that that particle was the postulation of neutrino. Neutrino and antineutrino. So this is the postulation of neutrino and antineutrino. This is the typical particle, new particle. Just like neutron is called new. Here neutrino also new particle, which is also coming out, means when neutron is decaying to proton and when there is emission of a beta negative particle, there is also emission of another particle which is neutrino or antineutrino. This is the beta negative here, charge. This is the antineutrino or neutrino also. Both are possible, but I have to explain you when neutrino, when antineutrino. So this decay of, or you can say proton decay to neutron and beta positive, the emission of a neutrino or antineutrino. This is the antineutrino and this is the neutrino. So remember that this particle emission of neutrino and antineutrino, it is observed that the natural decay, beta decay, is not simply emission of beta particle, but some other particle also. And this is a typical particle, a special particle. The property of neutrino or antineutrino special is mass zero almost, means negligible. Mass zero, charge zero, velocity, light velocity. And its property, important property is it is fermion, means it is spin. It is half H cross, just like electron. So it is very similar to electron. So it is a typical particle. Remember that this was discovered after several years of its theoretical postulation, and the group who discovered this, they got Nobel Prize on the discovery of neutrino. So this is not now only a theoretical particle, this is experimental particle available in nature. It is observed very in large number nearby the reactor, etc., where a lot of radioactivity is there. So neutrino or antineutrino are existing in nature, and now beta decay is not emission of simply beta particle, electron or positron, but emission of another particle. This is for the conservation of energy, because when this is constant, now here what that E beta plus E of the neutrino or antineutrino, this total energy is equal to Q beta. That this is the maximum energy, or you can say E end. Maximum energy, total energy, this is distributed. This maximum energy is taken by two particles. If this is large, this is small, this is small, this is large. Means here, if this energy is taken by beta particle, the rest of the energy taken by the neutrino. When beta particle is going with the maximum energy, neutrino is going with the minimum energy, like that. So this energy conservation and also spin conservation. Here, spin conservation also, because you can say this spin is not conserved here. Here half. And if this is not there, then half and half. You cannot conserve, because this becomes 1 or 0. This is half. So this is also half. Now it is possible that the result of this gives 0 and this half is conserved. Or this gives 1, then 1 and half are opposite, so the result becomes half. So for the conservation of spin also, it was thought that neutrino or antineutrino must have half spin, just like electron. So neutrino also, antineutrino also, they are having the some property which is similar to electron, that is the spin. Otherwise it's moving, it is never at the rest. Rest mass is 0. Mass 0 means rest mass 0. So this is the, you can say, rest mass. It is never at rest. It is always moving with light velocity. Its interaction probability is almost 0, very small, because it has no charge, no magnetic field. So this neutrino, antineutrino, they don't interact with the matter by electromagnetic interactions, because they don't have charge, they don't have any magnetic property, and the mass is almost rest mass 0, so there is no gravitational force also. So the interaction of neutrino and antineutrino with matter is almost 0. Only one interaction, reverse beta decay. By the method they are produced, they may have reverse beta decay. So by reverse beta decay they were discovered. Rhines and Cohen, they did experiment and they got Nobel Prize also. So antineutrino and neutrino is a real entity in nature. And remember that when I say here antineutrino, why here antineutrino? Because two antiparticles cannot come together. Or two here, because there is one more conservation law in nature, that is lepton number in the particle physics. Lepton number means electron is electron, neutron is electron. So lepton, two leptons here, that is the rule. Lepton and antilepton can combine. So this is the, remember, this is the particle, this must be antiparticle. Here this is antiparticle, so this must be particle. Because lepton number of particle and antiparticle is different. If this is +1, this is -1. Or this is +1, this is -1. Lepton number. So lepton number is here 0, here 0. Lepton, to conserve the lepton number of the particle, there should be antiparticle. And here this lepton number, it is not lepton. It is a hadron. So here proton and neutron balancing, here it is a lepton. So if this has got minus lepton number, this is the antiparticle, then here we should have particle, so that lepton numbers are conserved. So for the conservation of lepton number in particle physics, here we cannot have, this is a particle, this is antiparticle. So antiparticle and here should be particle, so that they have reverse, they have different lepton number. Antiparticle comes with the particle, particle comes with the antiparticle. So in the beta decay, negative beta decay, it is antineutrino and not the neutrino. Neutrino is with the positive beta decay. So all this is now experimentally confirmed. So it is the beyond of the +2 scope, so I will not explain all other experiments of the detection of neutrino, antineutrino, etc. I will not explain the interaction of neutrino with the matter, because this is the beyond the scope of the +2 physics. I am talking now +2 physics. So remember that there are experiments also for the detection, detailed experiment, Rhines and Cohen, very special experiment done by the like these two people. Okay, so this is the beta decay, negative beta decay and positive beta decay, and that is a natural transformation of the system into other element, or other element, say isotope, that is called isotope. That means elements of same mass, means because mass is not changing, but different charge. It can be charged maybe either plus or minus. So emission of this is called isotope of same element. And then we have say alpha decay. Alpha decay is another process where we have emission of a particle, emission of particle similar to helium atom. In fact, alpha particle is doubly ionized helium. We write alpha particle and here helium, which is say like this. The same thing, because it is 2 charge plus unit and 4 mass. So helium, alpha particle is helium. Charge W means helium from which 2 electrons are removed, atomic electrons are removed. Rest remaining the charged helium gas, helium particle. So this alpha particle also, you see, this doesn't exist inside the nucleus. Alpha particle is not present inside the nucleus and it is coming out. I give example, say uranium 92 is the charge, 238 is the mass. Uranium 238 is decaying by emission of twice He4 plus 2 unit. And just like alpha particle means 2 electrons removed from the helium. And plus uranium decays by emission of 4 mass less and 2 charge less, charge 2. So here 90 charge and here 234 mass. So 90, 234, this is the thorium. 90 thorium, 234 mass. So uranium is transforming. This is natural transformation. Uranium is transforming to the thorium in nature. Very, very long lifetime, 10 to the power 6 years, by emission of a helium-like system, doubly charged. So means 2 unit positive charge. And this is the residual nucleus, this is the parent nucleus, parent or daughter or residual, and alpha particle emitted, plus there must be some Q of alpha decay, Q alpha, energy of alpha decay, the difference of masses of the initial and final product. So alpha is produced. Alpha, how? You see, alpha is not inside. So how alpha is coming out? In this, I will not explain the emission of alpha particles. So that means I am not going to discuss Gamo's theory of alpha decay. But simply I will say here that it is quantum mechanical explanation, because alpha particle is charged particle cannot come out from the potential band, because energy of this is about 4 to 5 MeV. And 4 to 5 MeV particle and the potential height is about 30 MeV in the, say, uranium. So how alpha particle can come out from a 30 MeV barrier height from the nucleus of uranium? So this is the height of the Coulomb barrier. This is the potential. So alpha particle is sitting here. This may be energy of alpha particle. Say 5 MeV, say. And this is 30 MeV, potential barrier, potential barrier, or you can say B, potential. So this, how alpha particle is coming out from here? Classical physics cannot explain, and I will not explain here also, because it's out of the scope of +2 physics. Gamo's theory of alpha decay, quantum mechanical, that is tunneling from here. Just you have teeth in the prison cell, they hit the wall and repeatedly, 1,000 times, and they make hole and they come out. That is called making tunnel. So here alpha particle also making tunnel here, and by striking the surface of nucleus, it is digging here, making tunnel, and it comes out here. It will not come like this because the barrier height is very high. So the emission of alpha particle coming out here is a quantum mechanical process. It can be explained only by the probabilities, because if there is very small probability, that will give the result which can be explained, theory and experiment both. But here I will say only that alpha particle, one question I can say that this has got 4 particles, two protons and 2 neutrons. From uranium, how it is that 4 particles are coming out in natural process? Because nucleons means neutrons and protons, they are bound in the system here. When bound neutron protons means around 7 MeV energy is required to make 1 proton or 1 neutron, that is 1 nucleon free from here. So we are not providing energy here. If we are not providing energy here, how this 4 particle system is coming out? Because 1 particle cannot come out because it is bound. Then how 4 particles coming out? That can be also explained, because when there is a formation of alpha particle, there is mass defect, means mass loss. When 1 proton and 1 neutron combine together to make a deuteron, there is mass loss, means mass of the deuteron is less than the total mass of 1 proton plus 1 neutron. That is the mass loss. That is the binding energy. So when system is bound, there is some mass loss. To make the particle free, you have to provide the energy. So when the system was formed, and means alpha particle is formed by combining 4 nucleons. When 2 nucleons combine, there is mass loss, deuteron is formed. 3 nucleons combined, triton is formed, tritium is formed. 4 nucleons combined, helium is formed. So the mass loss when alpha particle is formed inside the uranium is more than the energy required to make 4 nucleons free. Then I give example that about 28.3 MeV is produced, is available. 28.3 MeV energy evolved when alpha particle is formed inside this. And only 28 MeV is required to make 4 nucleons free from uranium. So energy required is less, while energy evolved is more. And energy evolved is natural energy by mass loss, by mass defect. So here this alpha particle, you can say alpha particle binding energy is negative. Then negative binding energy means means energy when alpha particle is formed is more than the energy required to make it free. So in all heavy ion nuclei, alpha particle is not bound. Binding energy either is 0 or negative. Alpha energy positive means if they are free, they can come out. So alpha has got negative energy inside the nucleus, means the binding energy. It is not bound in fact. When alpha particle is evolved and produced here, it is not bound. Because when 4 nucleons combine together to make alpha particle, the energy is more. Energy evolved when alpha is produced. So that means alpha is free inside the uranium or any other element, radium, polonium, americium, whatever. There are so many heavy, almost all the heavy nuclei are alpha radioactive. Because alpha is not bound there. Alpha produced, it is free. It can, and with some kinetic energy also, it can come out. So uranium, just like the decaying to alpha and the thorium residual with the Q alpha, positive. So this decay is possible. Like this, So alpha particle, though it doesn't exist inside the nuclear system, but it is coming out because at the time of decay, it is produced by a combination of 2 protons and 2 neutrons, and we get alpha particle. So this is, when there is alpha emission, there may be gamma associated also, because when alpha emission is there, the system may be, residual system may be radioactive, excited states. And hence, in the natural radioactivity, with the beta decay and with the alpha decay, we also have, say, gamma decay. Well, gamma decay, what the gamma decay? You see, gamma decay is, you know, just like atomic de-excitation, we have here gamma decay means this excited state with energy, this 0, this is coming out. Because when alpha decay is taking place, beta decay is taking place, you may get a system here, Y system here, and this is Y is the excited state. So when Y is in excited state, it means it has got energy. This energy comes out and comes to ground state by emission of h nu, energy photon. And this photon is in the keV or MeV range, and this is called gamma, because gamma is gamma is of nuclear origin. Means energy is, say, keV, MeV, X-rays are keV also, EV photons. So in the atomic de-excitation, mostly we have EV or up to few keV radiations. But in the nuclear de-excitation, we have hundreds of keV to MeV. So these are gamma. Gamma particles are of nuclear de-excitation. Whenever excited states, you can say natural system, when say beta decay is taking, I give example of say X, by decaying by emission of beta particle, to Y, and this is beta particle. Well, this is coming here, then this comes down by emission of gamma, this also gamma, and this is 0. This is excited states E1, E2. So this beta decay, while the system remains excited, that comes to the ground state by emission of gamma. So these radiations, which are the energy quanta, comes out in nuclear de-excitation. This is a beta particle, so these are called gamma radiation. So gamma radiations may be associated with the beta decay. Similarly with alpha decay also. Alpha decay we have say alpha coming out like this, because it's the charge, this is the X, alpha coming out, and we get Y. So this is the alpha coming from X, alpha coming out, we are making this side because charge is changing. 2 unit charge is going with the particle. So residual system has got less charge. So we show on this side, beta decay, charge increasing by 1 unit. Because electron is going out, negative particle, so positive particle. The rest system, residual system has got positive charge. So charge increasing. So we have charge becomes from Z to Z plus 1. Here charge becomes Z minus 2. So we show left side, this we say right side. So these radiations, alpha, beta, they give systems which are in excited states. And excited states come to ground state by emission of radiations. Those are the radiations, we call them gamma. So gamma decay is a process which is of nuclear de-excitation. X-rays or photons are emitted in the atomic de-excitation, like we have hydrogen spectrum, Balmer series, Paston series, Lyman series, Fund series, etc. Those radiations, de-excitations they are photons of ultraviolet energy range, visible energy range, like that. So those radiations are photons, and similarly nuclear de-excitations we have energy range in the keV to MeV, and these we call gamma rays. So difference in gamma rays and the photons is only energy range, or the origin also. Those are origin of atomic de-excitation, gamma rays are of origin nuclear de-excitations. So these three processes, alpha decay, beta decay, gamma decay, are natural methods of nuclear transformation, nuclear transmutations. Now I give an example of, say, natural, this is natural and artificial. Artificial means man-made system, man-made decay. How the we transform the system to the other system by, say, nuclear de-excitation, by the nuclear reactions. So nuclear reactions also process, nuclear reaction is also a process of nuclear reaction means artificial transmutation. Means you are having a system X and you are bombarding the system by a particle. This is incident particle. Incident projectile, you can say. This can be any particle, neutron, proton, deuteron, alpha, heavy ion, anything, and P, alpha, deuteron, etc. And heavy ion. Heavy ion means heavier than alpha particle. Any ion, oxygen, nitrogen, silicon, whatever. So this is the projectile. This is the target nucleus. So incident particle with E energy means these are energetic incident particles, so that they can go towards the nucleus. They are positive particles mostly, because negative is on the electron. So these particles can approach towards, because this has got positive nucleus. So we require energy so that to penetrate inside the nucleus. So this thing is target and the projectile. We get a new system here. You can say C. This may be compound system. And this C is compound system, means X plus X. This is not stable. This cannot, this is excited. So this comes out to a new system, Y. That's the residual. And then the Y, this is the emitter particle. Plus energy, or you write Q. There is the energy. So this type of artificial transmutation means you are bombarding a suitable target nucleus by a suitable projectile of a suitable energy to get this Y and this emitted particle. This is called nuclear reaction. So nuclear reaction is a process where either one, this can be a target only of one nucleon like hydrogen. When one nucleon or more than one nucleon collide with the another system, this can be also one nucleon or combination of nucleon. When a nucleon or a combination of nucleon is sent towards a target nucleus, which can be also one nucleon or more nucleon, then there is a transformation of energy and momentum. Many collisions may take place and there is energy sharing between this system, and this system is formed for temporary time, and then this stabilizes by emission of a particle. This can be a single particle or a single nucleon like a neutron proton, or this can be combination like alpha particle, deuteron, or also heavy particle, and the residual system is there remaining. So so whatever you want to make here, you can get. Remember earlier people were trying long back to convert the, you can say, less important elements into the gold. The chemists were doing like this by some chemical reactions to convert into gold. But that was very difficult. But this nuclear reaction is possible to convert this X into this Y, which may be gold. To convert other nuclei, any select proper nuclei with the proper target, a proper projectile and proper target to get the gold. This may be gold. But remember, for the production of gold by this, it becomes very costly because you have to make energetic projectile, and for that we have to get an accelerator, accelerating machine costing crores of rupees to get this projectile. And then we get this amount. The amount of this is very small, few nuclei. So traces of that. And hence, to conversion of this X element into the gold is very, very costly affair. But earlier people thought that can be get like this, but it becomes very difficult, very costly. So people left that. But this transformation, artificial transformation, means conversion of X element into a new element by selecting proper projectile, proper target. We get residual system Y. So this is known as artificial transmutation, and this is called nuclear reaction also. So nuclear reactions is, well, I will give some more details example to you of of the nuclear reaction. Say I have So I gave you example. Earlier reactions which were studied by the scientists, say, was 2 helium-4 starting alpha particle interacting with, say, nitrogen 7, nitrogen 14. This was the earlier experiment done by the Rutherford group, and we got, say, X plus a proton, means 1H1. Well, then you can see that what this X can be, that you get, what this X can be, that you can see by the combination of, so this is the mass, means 2 helium-4 interacting with the 7 nitrogen 14 the emission of proton, then 8 oxygen 17, 1 proton. Because here this plus 1 charge, this is plus 2, this is plus 7, so 9, this becomes plus 8 plus 1, 9. So charge conserved, mass 14, 18, this is 1, so 17, 18 conservation. So alpha particle interacting with the nitrogen, we get oxygen 17 and we get proton emitter. So this was the earlier transmutation, means conversion of nitrogen into oxygen. So artificial transmutation means conversion of one system into other system by selecting proper target and proper nucleus to get this system. So this system is known as nuclear reaction. And here remember that nuclear reaction here, all conservation laws you must know. Conservation of mass and energy is there, conservation of linear momentum will be there, conservation of angular momentum will be there. That means spin of both sides will be same, like that. Conservation of baryon number, conservation of lepton number, all those conservation laws of particle physics and nuclear physics are obeyed here in any nuclear reaction also. And we say that I will not be telling any detail of the nuclear reaction, but here I can simply say that one important method of a nuclear reaction is theoretically known as the formation of compound nucleus and its decay. Formation of compound nucleus and its decay means when this system combined here, we get the C for some time, means this addition of this gives you, this is called compound nucleus, and this now decays. So formation of compound nucleus and its decay. So decaying like this. Only this thing is very important at the lower energy. Higher energy we have some other theories, pre-equilibrium decay, direct reaction, etc. I am not going to tell all those details, but we have compound nucleus, decay, means this is called equilibrium decay. And then we have a pre-compound or pre-equilibrium. Decay. And then we have direct reaction. So these are the processes, depends upon the energy. Lower energy we have, theoretically be explained by compound nuclear formation, higher energy be explained by direct reaction, or in the middle means slightly higher than this energy, medium energy, because this is the pre-compound. Means before the compound nucleus is formed, the system decays. So this is higher energy, this is medium energy, this is the lower energy. These are the processes to explain the compound nucleus, to explain a nuclear reaction. By compound nucleus, by pre-compound, by direct reaction. But I make now one most important, you say, diagram to explain the reactions. That is the, say, we have here X target, and we have, say, x, small x, coming from this side, say, for the interaction. This is the projectile. Well, this may come like this, X. This is called elastic scattering. These are type of reaction that projectile X comes towards the target X, and then it comes to initial channel, means whatever channel, whatever the quantum parameters this projectile is coming with energy, momentum, etc., it gets back without appreciable energy loss, and this interaction is called elastic scattering. X is now scattered back without any change of energy state, etc. So this is elastic scattering. And then we have, say, after this, when this X is absorbed here, it becomes X plus X. Then this is called, this is absorption. Now here, absorption. Means X is absorbed and we get now a new system. This is absorption, means this is now X plus X, or C. This is X plus X. And this is now moving here. X plus X moving here. So here again it is possible that this X plus X, and here after the absorption, again X is emitted out here. Again X comes out from the compound. This is the compound system. X plus X. Compound system. Here X comes out means the X is coming out, decay is coming out means, so this is called independent particle system. This is compound elastic scattering. Means coming out the same channel after formation of compound nucleus, compound elastic scattering. And this is possible that after absorption here, that here just interaction, this system decays. This system decays before this X is formed, before this C is formed. This is direct reaction, direct and pre-equilibrium so these interactions and multiple processes. Here you can have direct reactions, also you can have multiple decay, and you can have, say, here the system is formed, compound nucleus system is formed. Here this X is coming out, and this maybe Y may be going like this. This is also elastic scattering, compound elastic. And now this can decay by to different channels. That this can decay to the, or I can show here, because this decays, but decay like in different channels means here the emission of Y1 particle, Y2 particle, Y3 particle, and different particles are coming out after the interaction, and here we get this is coming out, and remaining thing here this plus Y1 plus Y2 plus Y3. These are residual systems, means residual daughter nuclei and emission of different particles. So this is compound decay. Compound nucleus decay. So like this, the reaction is possible by elastic scattering. By elastic scattering after formation of compound nucleus, that is compound elastic scattering, or direct reactions and pre-equilibrium. Here it may be multiple interactions also. And here the direct reactions are, stripping and pick-up reactions like that. Stripping, there are some reactions, stripping, pick-up. These are the direct reactions. And here the compound system is formed. That compound system may decay into different channels, means emission of different particles with different energies, and remaining systems which are residual systems. So this gives you the diagram of a nuclear reaction. Nuclear reaction, or this is the artificial transmutation, means you are changing one system X into a new system Y by selecting a proper projectile, a small x, and by selecting of different types of reaction like this. So this gives you a picture to explain the nuclear reaction. So this is the nuclear reaction, means this is the artificial transmutation, natural transmutation of the nuclei by alpha decay, beta decay, gamma decay, and by nuclear reactions. These nuclear reactions can be thousands of nuclear reactions, separate nuclear reactions, induced by proton, induced by neutron, induced by light ions, induced by heavy ions, also may be induced by gamma rays, high energy gamma rays also, when nucleons are produced or mesons are produced. So this is a picture of nuclear reaction. Okay friends, I will stop now here, and maybe tomorrow I will solve some problems from the nuclear decay, radioactive decay, all the nuclear reactions, etc. So tomorrow when we meet, I will be solving some problems. Okay, thank you very much.